So class, any number inside this place must be greater than or equal to 0 for the function to be continuous. So let us find the range that will make this function continuous. Class, but actually I will have to find the points at which it should not be continuous, right? We'll first find the point that will be continuous, and every other point apart from that point will be this. That's why they say point or points, right? And it could be more. Class, let us solve this. This is a quadratic equation. This is minus 18, this is minus 1. Minus 1 times minus 18 is positive 18. When solving quadratic, we're looking for to solve by factorization. Of course, you can use shortcuts here, which I'll teach you later. I've taught some people already. 18, what are the two numbers multiplying 18? 6 and 3, right? 6 times 3 is 18. So this can be minus x squared plus 6x plus 3. Change this 9x to 6x plus 3x minus, must be greater than or equal to 0 for this function to be. Minus x squared, let's factorize now. Factorize this first to factorize other. What's common here? Let's bring out x. Let's bring out minus and let's bring out x. Bring out minus and x. What we have there is x minus, because minus and minus gives you plus. X minus 6. If we bring out plus 3 here, x minus 6. When you factorize well, the two brackets are the same, right? It is minus x plus 3 must be greater than or equal to 0, or x minus 6 must be greater than or equal to minus x. When plus 3 comes here, it becomes greater than or equal to what? Minus 3, right? But class, remember this minus rule. For this two, if minus x is greater than or equal to minus 3, then x is less than or equal to 3, right? Or x is greater than or equal to plus 6. Class, these are the only 2 points that this function will be continuous. These are the only 2 points of continuity of this function. So every other point, this function will be this continuous. So class, at what points or points is this function discontinuous? At all real values of x, except what? 3. Except when x is less than or equal to 3, or x greater than or equal to 6. X less than or equal to 3, or x greater than or equal to 6. Because class, if you put 3 into this function, I bet you're going to have a number that is greater than or equal to 0. If you put 3 here, you have 3 squared is 9 minus 9 plus 9 times 3 is 27 plus 27 minus 18. You're going to have 0. Square root of 0 exists is 0. If you put 6 inside here as well, you have a number that is not a negative value. But class, what we're trying to avoid is to have anything that makes you to have a negative value in your square root. The function will not exist. The function will not do what? And if the function does not exist, it means the function is this. These are the only 2 numbers that satisfy this function, that can make this function continuous. These are the only 2 numbers that can allow this function to be what? So every other value of x, except these 2, the function will be this continuous. Class, if x is less than or equal to 3 and greater than or equal, can we write it in the form of interval? How can we represent the form? X is less than or equal to 3, but greater than or equal to 6. Class, x is less than or equal to 3 means 3 is greater than or equal to 3 is greater than or equal to x, but x is greater than or equal to 6. 3 is greater than or equal to x, but x is greater than or equal to 6. You can put it in form of interval. Class, this one is actually the point of continuity. Point of what? So, point of continuity will be all real numbers that do not satisfy this, right? All real numbers that do not satisfy. So I can even say r minus everything I have here. r minus this can be my point of discontinuity. But this is point of continuity. So point of discontinuity will be all real numbers minus these numbers. Now class, number 4, still on activity 3.4. That number 4 seems to be the last question on activity 3.4. At which point, question 4, under activity 3.4, at which point or points, there can be more, don't think it's just one point, is the function f(h) of x equals to x all over x squared minus 6x plus 8 discontinuous. This class, anytime they give you a fractional function like this, anytime you have numerator and denominator, and you have to find the point of discontinuity, class, just be thanking your God. Class, don't need to stress yourself. Just take the denominator and equate to 0 and solve for x. X squared minus 6x plus 8 equals 0. Then you solve for class. The values of x you get are the points of discount. Anytime you have a fraction, it's easier to solve for a point of discontinuity for a fractional function than a square root function. For a fractional function, just focus on the denominator and equate it to 0 and solve for x. Class, we factorize this to solve for x. For 8, what are the two products of 8, 4 and 2? Or minus 4 and minus 2. Let's work with minus 4 and minus 4 times minus 2 is plus 8. Or minus 4 minus 2 is minus 6. So we're going to say x squared minus 4x, split minus 6x to minus 4x minus 2 plus 8 equals to, factorize here, you're going to have x into bracket x minus 4. Factorize here, minus 2 into bracket x minus equals to, so x minus 2 equals to 0, or x minus 4 equals to, so x must be equal to plus 2 or plus, so therefore, there are 2 points. Therefore, there are what? 2 points of discontinuity. Of what? Of the function h of x. That is at x equals to 2 or at x equals to 4. So class, at these 2 points, why do we say these 2 points are the points of discontinuity? At these 2 points, this function will not exist. Because class, if you place 2 into this function, class, I bet you're going to have 0 below. And any number divided by 0 is math error. That means doesn't exist, doesn't. And any value of x that will make our function not to exist means that it's also a point of discontinuity. Another way of defining point of discontinuity is at what value of x will the function cease to exist. Any value of x that is placed into this function that will give you math error in your calculator, or that will make the function to be indeterminate or undefined, is your point of discontinuity. So thank you very much. We are done with activity 3.4. The next one will be activity 3.5. Thank you.